Dear students, in this section, let us see a numerical problem where we are going to appreciate the similarity analysis or the similitude analysis. Here, we want to arrive at the parameters for the either the prototype or the model. Let us go through the problem. Two geometrically similar pumps. So we have two pumps. The two geometrically similar pumps are running at the same speed of 1000 rpm. So since there are two pumps, let us have them as 1 and 2. So let us call them as N1 and N2. They are running at the same speed of 1000 rpm. So N1 is also what? 1000 rpm. N2 is also what? 1000 rpm. One pump has an impeller diameter of 0.3 meter. So let us take D1 is given as what? 0.3 meter and lifts water at a rate of 20 liters per second. So the unit is liters per second, which is nothing but the flow rate. Flow rate Q is given. Q1 is what? 20 liters per second against a head of 15 meters. So they are given the head also for the first pump. So we can see H1 equal to how much? 20 meters. So what may be the question? So they told there are two pumps. One pump, both the pumps have the same speed, 1000 rpm, and the data for the first pump is given as the diameter is 0.3 meter, Q1 is 20 liters per second, H1 equal to 20 meters. What may be the question? Yeah, there's no need to study the question. We can frame our question on our own. So what may be the question means, what may be D2? What may be? They also given another thing. Determine the head. So they are asking what is the head. Determine the head and impeller diameter. So they are asking what is the impeller diameter of the other pump. So they are asking for the second pump. To deliver half the discharge. To deliver what? Half the discharge, which means Q2 equal to what? What is the relation between Q2 and Q1? Q2 equal to half Q1. So the discharge by second pump is only half the discharge of the first pump, which means Q2 equal to half Q1, which means half into 20 liters per second, which is nothing but what? 10 liters per second. So we can see they are given N1, N2, D1, Q1, H1. They are given Q2 also. We want to find D2 and H2. We want to find D2, H2. By means of which analysis? By means of similarity analysis. Okay. Let us continue further. These are the data given and D2 and H2 are the things asked. It is a pump. So we can make use of the specific speed of the pump, or already in the previous session we have derived the formula for the specific speed of a pump and the specific speed of a turbine. You can refer the previous video, or let us derive it within 2 minutes here also. It's not a great task. So the purpose of a pump is to lift the water to a particular height at a different flow rate. So the heroes of the pump are Q and H. Q and H. So what is we want from a pump? To lift water from the ground level or below the ground level to 10th floor or 20th floor. So the head is required, as well as how much amount of water I have to store. I want to store some water in the overhead tank. So that is something about my flow rate. So these are the two heroes of a pump. Now Q equal to what? Area into velocity. What about area? Pi by 4 d squared. What about velocity? Velocity is nothing but the fluid velocity. Is nothing but square root of 2gh. Square root of what? 2gh. Okay. Now what I can write means Q is direct proportional to d squared into square root of h. What happened to this pi by 4 and 2g, square root of 2g? They are constant. Since I remove the constant, put proportionality, I am going to take only the variable. So Q will be direct proportional to d squared into square root of h. One more term we have defined, that is phi is nothing but the speed ratio, which is nothing but U by capital V. U is nothing but the impeller speed. Impeller speed means the blade speed is given by pi dn by 60. Whereas the V is given by what? Square root of 2gh. V is the what? Velocity of the fluid. This is the velocity of the solid. Solid means blade velocity. Blade velocity. So now we can see this phi. Phi is also a constant. Why? The ratio of the velocity is nothing but a constant. So phi is direct proportional to dn by square root of h. I hope you will agree with me. Phi is direct proportional to what? dn by square root of h. From this, what is d? D will be directly proportional to square root of h by n. You may wonder what happens to phi. Phi is a constant. It's a ratio. So there's no need to worry about that. We want to take only the variables. So d is directly proportional to what? Square root of h by n. From this, what is d squared? D squared is directly proportional to h by n squared. H by what? N squared. So now we can put instead of d squared, I can put as what? H by n squared into square root of h can be written as what? H power half. So I can write q is directly proportional to h power 3 by 2 by n squared. How this 3 by 2 come? Because it is having a power of 1. This is having a power of half. 1 plus half will be 1 and half. 1 and half is nothing but what? H power 3 by 2 by n squared. So we arrived at the formula q is directly proportional to h power 3 by 2 by n squared. Now I want to make q is equal to, I have to add a constant because I want to remove the proportionality. So q equal to k into h power 3 by 2 by n squared. Now we can define the meaning of the specific speed of a pump. What is called as the specific speed of the pump? The pump should be able to deliver 1 meter cube per second of water or any liquid through a height of 1 meter. Then the speed at which the shaft will rotate is called the specific speed of the pump. I will repeat once again. As I told you earlier, the heroes of the pump are the Q and H, the discharge and the head. So if I can maintain 1 meter cube per second of flow rate to a height of 1 meter, to a head of 1 meter, then the speed at which the shaft rotates is called the specific speed of the turbine. Sorry, of the pump. You may ask, then what is the power should be supplied? You can supply any power. Electric power, you can supply any power to the motor, to this pump. Such a way, this pump should be lifting what? 1 meter cube per second of water to a height of 1 meter. Then the speed at which this shaft rotates is called the specific speed of the pump. So I will make it now. Q will be equal to what? 1 meter cube per second. 1 meter cube per second is nothing but 1000 liters per second. So you can imagine now. 1 meter cube means you will not think. But within a second, I want to pump 1000 liters of water. So it's huge amount. So 1 meter cube per second to the height of what? 1 meter. 1 meter is up to this side, not this side, maybe up to this side. So this amount of height I have to lift the water. Then at that time, my speed will become the specific speed. My speed will become what? N will become what? Ns. So substitute over here. So Q will be equal to, Q will become 1, K, H will become 1. What about N? N will become Ns squared. So from this, what is K? K will be equal to Ns squared. So we got the value of K equal to what? Ns squared. Substitute the value of K equal to Ns squared in this equation. So I will end up with what? Q equal to Ns squared H power 3 by 2 by N squared. Here Ns is called the specific speed. Okay, and H is the head. From this we can obtain what is Ns. From this equation I can get what is Ns. Ns squared will be equal to Q into N squared. I am just cross multiplying by H power 3 by 2. Okay. So if I want to take the square root of this term, it will become Ns. So it becomes square root of Q. N squared will become N. H power 3 by 2 will become what? H power 3 by 4. When I am taking the square root, I will get like this. So for what is finally I ended up with? I ended with the formula saying Ns equal to what? Square root of Q into N by H power 3 by 4. This is not the specific speed. What is the meaning of specific speed is also a ratio, which means the specific speed of pump 1 should be equal to the specific speed of pump 2, which means square root of Q1 N1 by H1 3 by 4 should be equal to what? Square root of Q2 N2 by H2 whole power 3 by 4. So this is the final formula what we arrived from this specific speed. In the exam, if you know the formula for the specific speed already for a pump, there's no need to derive all these things. Directly you can go to the formula. What is the formula? Ns equal to square root of Q into N by H power 3 by 4. Then you can make 1 on one side, 2 on the other side. You can compare 1 and 2. From this we can get the required outcomes. On continuing further with the given data, as well as the specific speed formula, ns is equal to square root of q1 by into n1 by h1 whole power 3 by 4 is equal to square root of q2 into n2 by h2 power of 3 by 4. Now you see, this is the equation we got. Whether you know q1, yes, I know q1. Whether you know q2, yes, I know q2. Whether n1, n2 is known, yes, n1, n2 is known. h1 is known, yes, h1 is known. So one equation, only one unknown. What is the unknown? h2, we can easily find it out. We can easily find it out. But students used to make mistake. What the mistake is that they will put the q1 in liters per second itself, which is wrong. Which is wrong. So I am telling, we have the formulas of the specific speed and comparing with the model with one pump with the another pump. Okay, it is 1 and 2. Out of this equation, there are 6 variables. Out of the 6 variables, we know the 5 variables because q1 is known, q2 is known, n1 is known, n2 is known, h1 is known. So we can find the h2. So very simple. One equation, one unknown, we can solve. But the thing is, we should not make mistakes in the units. What is 1 liter? 1 liter is nothing but, if I'm going to take a cube of, say, breadth is 10 centimeter, length is 10 centimeter, and height is what? This length is 10 centimeter, breadth is 10 centimeter, and height is 10 centimeter. Now, how much volume it will occupy will be called as 1 liter, which is nothing but what? 10 into 10 into 10, centimeter into centimeter into centimeter will become what? Centimeter cube will be equal to what? 1 liter, which means 1000 centimeter cube equal to 1 liter. Got it what I'm telling? So if I'm going to have a cube of length 10 centimeter, breadth 10 centimeter and height 10 centimeter, the volume of water which will be occupied within this container is called as 1 liter, which is nothing but what? 1000 centimeter cube equal to 1 liter. Okay, fine. Now, we know that 100 centimeter equal to what? 1 meter. So 1 centimeter will be equal to what? 10 power minus 2 meters. I am dividing both sides by 100. So it becomes 10 power minus 2 meter. I want 1 centimeter cube, which means I want to raise the power of cube on either side. 1 cube, centimeter cube. So it will become 1 centimeter cube will be equal to 10 power minus 2 into 3 will become 10 power minus 6 meter cube. So 1 centimeter cube equal to 10 power minus 6 meter cube. I want 1000 centimeter cube. 1000 centimeter cube will be equal to what? Multiply both sides by 1000. So 10 power minus 6 into 10 power plus 3. Isn't it? So the answer will be 1000 centimeter cube is equal to 10 power 3 meter cube. 10 power minus 3 meter cube. 10 power minus 3 meter cube. So what is this 1000 centimeter cube? 1000 centimeter cube equal to 1 liter. So 1 liter equal to 10 power 3 centimeter cube or 10 power minus 3 meter cube. So hereafter we will follow this formula. It's very simple. What is the formula? 1 liter is equal to 1000 centimeter cube. Otherwise called as what? 10 power minus 3 meter cube. This also we can write as what? Either 10 power plus 3 centimeter cube or 10 power minus 3 meter cube. So here they given in liters. We have to convert into what? Meter cube per second. So the liters, if I want to convert into meter cube means I have to divide by 1000. I have to divide by what? Or multiply by 10 power minus 3. Both are same. I have to multiply by 10 power minus 3 or divide by 1000. So the value of Q1 will be equal to 20 by 1000. 20 by 1000 meter cube per second. So first your idea should be converting the liters per second into what? Meter cube per second. Q2 will be what? 10 liters per second. So 10 by 1000 meter cube per second. So we'll get 20 by 100. Sorry, 2 by 100, which will be equal to what? 1 by 50. 1 by 50. So we will get the thing. Here will be what? 1 by 100. Here will be getting 1 by 100. Now you substitute the value of Q1 as what? Q1 as what? 1 by 50. What is N1? 1000. What about H1? 15. Whole power 3 by 4. Will be equal to what? What is Q2? Q2 will be equal to 1 by 100. Square root of 1 by 100 into, what is N2? N2 is also same speed. By H2 whole power 3 by 4. We don't know this one. So if you want, I can erase this particular middle section. so that you can understand easily. So you can see here, this left hand side is this one, the right hand side is this one, only one unknown. From this we can find the value of H2, which will be coming around 9.44 meters. So if you go do the calculations, you simplify it, finally you will get an answer of what? H2 equal to 9.44 meters. On continuing further, thus we got the value of H2 to be what? 9.44 meter. Now what we have to get? We have to get the value of D2. We want to get the value of what? D2. Okay, we can go by any method. I told you already, phi is nothing but what? U by capital V. What is U? U will be equal to pi dn by 60. What about V? Square root of 2gh. So what will be phi? Phi will be directly proportional to what? D n by square root of h, because all the terms pi, 60 and square root of 2g are constant. Here I told phi is also a constant. Phi is also a constant, which means d1 n1 by square root of h1 is equal to what? d2 n2 by square root of h2. Now I'm stopping here. Why I'm stopping here means, in the previous expression of specific speed, where n is equal to what? Square root of q into n by h1 power 3 by 4. In this term, doesn't have any diameter. But we want to now find the diameter. So you try to go for some expression which will have the diameter also. So I have taken this expression. So we found that what? d1 n1 by square root of h1 will be equal to what? d2 n2 by square root of h2. We know d1 is given 0.3 meter. We know n1 1000. We know n2, that's also 1000. We want to find what is d2. Whether you know h1, yes, I know. What is h2? Yes, I know. H2 is also given us what? We have found out. So we know h2 also. So only unknown is what? d2. We can easily find it out. So let us proceed. What is d1? 0.3 into 1000 by square root of 15 is equal to d2 into 1000, because n1 and n2 are the same speed, is given in the problem, by square root of 9.44. So the unknown is d2. So the unknown is what? d2. On evaluating this d2 is coming to be around 0.238 meters, which is nothing but d2 equal to what? 238 mm. The diameter is slightly lesser than the diameter of the first pump. It is nothing but what? 0.238 meters. I hope you enjoyed the problem. So I will repeat the problem once again. We have made use of the similarity analysis. We have arrived at some non-dimensional numbers and tried to equate them to get the unknown variables. So in this particular problem, they are given n1, they are given n2, they are given q1, they are given q2 also, they are given h1, they are given d1. So they are asking what is h2, d2. First we try to derive the formula for the specific speed, which is not required in this problem. If you know the formula directly, you can substitute here and try to get for the pumps 1 and 2. The only unknown is what? Your h2. So you can find the h2, which comes out to be 9.44 meters. Once we found the value of h2, now it's our responsibility to find d2. So try to come with some equation which will have d1 and d2. So I have make use of phi is nothing but u by v, which is nothing but phi will be directly proportional to dn by square root of h. So it will become d1 n1 by square root of h1 will be equal to d2 n2 by square root of h2. Here all are known, only unknown is d2. So when you found out the value, d2 is coming out to be around what? 0.238 meters, which is nothing but 238 mm. So it's a very simple problem. Within 4 to 5 minutes we can solve. I have taken nearly some 20 minutes, but this much of time is not required since I want to explain. As well as I have derived some expression, it took me this much of time. Otherwise we can solve this problem within some 3 to 4 minutes. Thank you.